All right, Algebra 1B students, welcome to part 2 of lesson 7-2. Please open with me to page 427 in your books. We're going to be looking today at exponents as fractions. A couple of videos ago we looked at exponents of zero and negative numbers. Today we're going to look at exponents as fractions. All right. The first thing that you will see at the bottom of page 427 there, it tells you that exponents can also be expressed as fractions, and those are called rational exponents, which I have underlined here. Rational exponents are fraction exponents, okay? Rational numbers in the exponent, all right? Now, recall that 3 to the second power means 3 times 3, which equals 9, okay? Basically, what we're going to do today is write these expressions backwards in the other order, okay? So it says you can write the same expression using rational exponents 9 to the 1/2 power. The equation 9 to the 1/2 power equals b indicates that b is the positive number that when multiplied by itself gives us 9, okay? So I'm going to break that down for you just a little bit to help you understand why we need it to be 9 to the 1/2 power, okay? So 9 to the 1/2 power, what this really means is we need a number that when we multiply two of them together, we get 9, okay? So that's what the 2 is doing right down here in the bottom of our fraction. That means we need a number that when we multiply it 2 times, we get 9. Well, what number is that? Obviously, we should know that that is 3. If I list out 2 3s and I multiply them together, now I get up to 9. So that's why your book says right here, 9 to the 1/2 power equals 3, because when we list out 2 of them, 1, 2, and multiply them together, we get 9. Okay? Let's look at another example so that we can see why this is not always going to be to the 1/2 power. Okay? What if we had 8 to the 1/3 power, or the 1/3 power? Okay? This is different because now we need a number that when we list 3 of them, we get 8. Okay? Some number that when we list out 3 of them and multiply them all together, we get 8. Hopefully, you can think through some of the small numbers and find out that that number is 2. If I list out 3 2s and I multiply them together, 2 times 2 times 2 again gives me 8. Okay? So, 8 to the 1/3 power equals 2. Okay, that would be the simplified version of 8 to the 1/3 power, because 2 is this number that when we list it out 3 times and multiply them, we get 8. Okay? So that's really what we're talking about. Some number that when we multiply it together that many times, we get the number we're starting with. Okay? So your book then, at the bottom of that page, says, in general, a to the 1/m power equals b means b multiplied m times gets a. Okay? So this number on the bottom of the fraction tells us how many times we need to multiply it. How many times we need to multiply it? M times, right? To get our big number here. Okay? In your practice problem set, here's what this is going to look like. The easiest version is going to be just like what I have just done with the 2 examples previous. Right? So if you flip over to the top of the next page, page 428, you will find problem 4 right here, okay? Which asks us to simplify these expressions with rational exponents, starting here with 81 to the 1/4 power. It's kind of blurry on the screen, so look in your book if you need to. Now, 84 to the 1/4, that 1/4, the 4 being on the bottom right there, tells me that I need to find a number that when multiplied 4 times, meaning when I list it out 4 times and multiply it all together, I get 81, okay? So it's perfectly fine if you want to go through kind of a guess and check method. Check and see if 2 works, check and see if 3 works, check and see if 4 works, and so on, okay? In this case, we find that 3 is that number. 3 times 3 is 9, times 3 again makes 27, times 3 again makes 81, okay? So 81 to the 1 over 4 power, if we simplified it down, would equal 3, okay? Now I want you to try it with A, B, and C right here. 16 to the 1/4 power, so look for a number that you can multiply together 4 times. That one you need 4 times to get 16. In letter B, you need something that goes together 3 times to get 27. And then in letter C, you need something that just goes together twice, or 2 times, to get 64. Okay? So take a look at those 3 problems. Pause the video, do those 3. When you're comfortable, come back with me, and we will look at a little bit more complicated version. So pause the video, do those 3, and then come back. All right, let's go on then to the middle of that page. And before we do, I want to just remind us that 1/2 plus 1/2 plus 1/2 equals 3/2, right? When we add fractions together, we add the tops of them, and the bottoms should all be exactly the same, right? 2, 2, 2, 2, all exactly the same. Okay? So look at what happens when we have something like this. Now it's not a 1 on the top of our fraction anymore, is it? It's not 9 to the 1/2. Now it's 9 to the 3/2. But I know from what we did in our last video about adding these exponents together that 9 to the 3 over 2 is the same thing as 9 to the 1 over 2 times 9 to the 1 over 2 again times 9 to the 1 over 2 again. Right? Because if I multiply all these numbers together, I should add their exponents. So 1/2 plus 1/2 plus 1/2 should now give me my 3/2 as my exponent, which is exactly what I want over here. Right? So 9 to the 3/2 is like listing out this 9 to the 1/2 thing that we did on the last slide 3 times. That's what the 3 is doing on top. Okay? The good news for us is we know what 9 to the 1/2 is from that last slide, don't we? 9 to the 1/2 we found before was 3, because if we multiplied 3 together 2 times, we should get 9. Okay? So 3 times 3 again, times 3 again, because these are all exactly the same expression. 3 times 3 times 3 again should give us 27. So what that means is 9 to the 3/2 power equals 27. Okay? Hopefully that makes sense to you, because we're now going to go on and look at a few examples, and I'm going to make you do a couple. So if you need to re-watch that section, zip back a little bit, watch me explain that again. When you're comfortable, let's scroll down. Problem 5, which you'll find right there in the middle of page 428. Okay. Now we're going to simplify expressions with rational exponents, but the top of our fraction in our exponent is not going to be a 1 anymore. Okay? This first example they give us is 64 to the 3 over 2. Well, that should be very much like the 9 to the 3 over 2 power that we just did up top, right? Just like up top. 64 to the 3 over 2 is like listing out 64 to the 1/2 3 times, because we know that 1/2 plus 1/2 plus 1/2 equals 3/2. And what do we have to do in order to add our exponents? We have to multiply our expressions together. That's why we have times symbols in between them. Okay? So again, we should know from the last slide in the last example what 64 to the 1/2 power is. 64 to the 1/2 is 8. So 8 times 8 times 8, multiply it together 3 times, and our answer is 512. Okay? So 64 to the 3 over 2 equals 512 because we listed out that 64 to the 1/2 power 3 times, multiply the 8's together. Okay? Now, I think you can do number 25 because it's exactly like the ones we just did. And I think you can do letter B and letter C here as well. But you'll have to notice that now we have 27 to the 2 over 3 power instead of 27 to the 3 over 2 power. So I will help get you started here. Please pay attention to this. 27 to the 2 over 3. Well, I know that 1 over 3 plus 1 over 3 will equal 2 over 3, right? So if I want to write my exponent fractions with a 1 on the top, I should make this equal to 27 to the 1/3 power times 27 to the 1/3 power so that I can add those two exponents together when I multiply the expressions. Okay? Hopefully that makes sense from our last video. If we want to add our exponents, we need to multiply our two expressions. Okay? So now 27 to the 1/3 times 27 to the 1/3. I think you can figure that out yourselves. And also look here at letter C. This one's kind of more of a challenge problem. That says 16 to the 3 over 4. So list out 16 to the 1/4 3 times and then solve. Okay? So do A, finish off letter B, and try letter C, please. Pause the video and do that. And then come back to me and we will just add in some variables real quick. And we will be all done and ready to practice. But we're going to need a lot of practice with this because it can get a little bit confusing, okay? So pause the video, take as much time as you need for letter A, letter B, and try letter C, asterisk, that's a challenge problem, and then come back. Okay. Let's add in some variables real quick. If you look at the top of the next page, page 429, this is our last example. We now have some expressions with letters, variables, and numbers all in them. And we're being asked to simplify those down. So we've been doing that a little bit back in problem 2 on page 426, where we had whole number exponents and potentially negative number exponents. Now we're going to do it with, yup, you guessed it, fractional exponents. Okay? So I'm going to look here at letter A for you in the got it number 6. Then I'm going to make you do B and D by yourselves. Okay? So letter A says 2 times C to the 3 over 5 times 2 times C to the 1 over 5. Okay? Now I know that because I have these numbers, these 2's out front, I can put those together and multiply them first, doing 2 times 2. And then at the end, I can deal with my C's. C to the 3 over 5 times C to the 1 over 5. Okay? I'm going to rewrite it like that. 2 times 2, I hope we know, is 4. And I'm timesing that by, now the question is, what is C to the 3 over 5 times C to the 1 over 5? Well, hopefully we remember from our last video that when we multiply two things that have the same base, but different exponents, all we have to do is take those two exponents and add them together. Okay? Add them together. So 3 over 5 plus 1 more over 5 should give us 4 over, bottom does not change. Please don't change the denominator. 4 over 5. Okay? So really this expression in the parentheses on the right is going to become C to the 4 over 5 power. So we have 4 times C to the 4 over 5, and we're done. That is as simplified as we can make this expression. Okay? So hopefully that makes sense how I did that rearranging. And then we're just applying what we learned in our last video to add these exponents together over here and rewrite that expression in a more simplified way. Okay? Your job now is to look here At letter B and letter D, part of the got it questions on page 429. Right? Letter B, you should be able to do very, very quickly. It's a straightforward application of the rule we learned in our last video. Letter D, you need to do quite a bit of rearranging. Okay? You should have 3 different things that you rearrange. Numbers first, then some J's, and then some M's. Whoops. Well, there you go. There's some M's for you. I'll even tell you that one's going to be m to the 1/4 power. And I'll even tell you this one's going to be j to the 2/3 power. Okay? I've helped get you started on letter D, but I want you to finish letter D, do letter B very quickly, and then you should be ready to start practicing yourself on that practice problem setting class tomorrow. Okay? So, once you've mastered these, you're ready to go. If you can't get one of these, please make a note to ask me in class tomorrow, and we will talk about it. I will do my best to re-explain or somehow get it to make sense to you. But that's all I have for now. Hopefully you have a great night, and I will see you in class tomorrow ready to work on those practice problems.